In this video, we're going to solve linear inequalities like you can see behind me. So remember, that's like our less thans, our greater than or equal tos, those kind of things. As well as not just solve them, but also graph them and find their interval notation as well. So I think the best way to do this is to have you just kind of follow along with me on a few, and then I think you'll probably get the hang of it. All right, on this first one, it says 2 minus 3x is, do you know what the sign is? Is less than or equal to 5. All right, if you don't know the difference between less thans and greater thans, probably want to start learning that, right? So it's less than or equal to 5. And with this, what we want to do is solve it just kind of like we did with our regular equations. And then when we get to the end, we'll kind of show you how to graph these. All right, so first off, I'm trying to get my x term by itself. So I need to subtract 2 to both sides like that. It's really easy to forget this negative. Don't do that. Say it's negative 3x is less than or equal to, and then 5 minus 2 is 3. Okay, and then if I divide both sides by a negative 3, one thing that's special about inequalities is if you multiply or divide by a negative, your sign switches. Okay, and this one, since we divided by, it's the one that we're doing it to both sides on, since we divided by a negative, we're going to now have x, this is going to be a negative 1, but our sign is no longer less than or equal to, it is greater than or equal to negative 1. Okay, as long as your x is first, the way that you can graph this, just draw a quick number line. I like to always put 0 and then the number I am working with. So in this case, negative 1. So my 0 would be more to the right. Negative 1 is going to be to the left. And then since it includes the equal to sign here, we're going to have a closed dot. Right, and then some teachers tell you how to graph this different ways. Some people do an arrow up above. Some people shade the line. There's probably other ways to do it as well. The way I'd like to teach is the shading. So you can do it either way. I'll grade it however you have it. But as long as our x is first and it's pointing a certain way, we're going to shade that way. So here's pointing to the right. So we're going to shade to the right. It's all the numbers greater than negative 1. Okay, let's try this one maybe a little bit quicker now. Oh, you know what? I forgot our interval notation. Really quick here. If I go back, the interval notation of this, the interval notation, the way I want to kind of explain it is just, it's basically a snapshot of the shading. All right, so we need to encapsulate it with either a parentheses or a bracket. And you do that, you use a bracket when there's a closed dot and a parentheses when it's either open or when it goes off to infinity or negative infinity. So here, to kind of show where it starts and where it ends for this shading, it starts at negative 1 and it goes forever to positive infinity. And we need to encapsulate these with those different signs. Remember, closed dots get brackets, and then either infinities or open dots get parentheses. So that is what your interval notation would look like. I about forgot that. Okay, in this one, let's see, if I were to solve this like a normal equation, I'd probably distribute my negative 4 in first. And now I would have 8 minus 8 plus 4x is less than or equal to negative 2x. Well, some easy math here. Those two are going to cancel. 8 minus 8 is nothing. So you could just get rid of those since they're combining like terms. And then I personally like to move my smallest x value, or whatever your variable is, in this case x. So I'm going to move that to the other side. If I add 2x here, plus 2x plus 2x, now all of a sudden I have 6x is less than or equal to nothing. There's nothing left over there. So we're going to say 0. And that's okay. It can equal 0. Some people freak out a little bit when you see that, but that's fine. To get the x isolated, I'm going to divide both sides by 6. And of course, 0 divided by anything is 0. So x is less than or equal to 0. And that's okay as well. That's a perfectly fine answer. We're just starting at 0, and we want all the values less than 0. So on my graph, since I'm just working with 0, I don't have another number here. I'm going to keep a closed dot, and I'm going to shade this way. All right, again, as long as your variable comes first, you can shade the way that your arrow is pointing. In this case, it's pointing to the left. All right, the interval notation on this one, we read it from left to right, so it starts here at negative infinity because it keeps going this way forever, right? Negative infinity, and then it stops at 0. And we encapsulate this with a parenthesis. And what's this one get? Bracket, right? It gets a bracket, just like that. Okay, by the way, be sure I can tell if yours is a bracket or a parentheses. If I can't tell, I will probably mark it wrong. Let's try two more. All right, two more for this video. In this third one here, it says 1 is less than 1 minus 1/2 x is less than 4. You'll notice in this problem, this is called a compound inequality because there are two or multiple inequalities in the same problem. All right, some people like to draw lines down each of those and kind of solve them in their three different sections. That's fine if you want to think of it that way. But you probably will have your x in the middle with your kind of two different answers on the outside. And then when we go to graph this, it's either going to be stuck in between those two numbers or it's going to be on either side of those two numbers. All right, so I'll show you kind of what I mean as we go and do it. So again, we have to solve this in sort of, it's like all three sides. And here to get, if I want to kind of get my x isolated, I first need to move this 1. So we're going to subtract it from all three sides here. It's going to cancel in the middle. And then on the left side, 1 minus 1 is 0. On the right side, 4 minus 1 is 3. And since I just subtracted, my signs stay the same. It's still going to be a less than. This is still going to be a less than. And I still have a negative 1/2 x in the middle like that. All right, to get rid of negative 1/2 x, I could do a couple things. I could divide by negative 1/2, or that's the same thing as multiplying by negative 2. So I might do that. Multiply all, oops, negative 2 is what I said. Multiply all 3 parts by negative 2. And here, since we're both dividing and multiplying by 2 and by 1, those are going to cancel, leaving me with just x in the middle. And then on the opposite sides, here we're going to have 0. Negative 2 times 0 is 0. Negative 2 times 3 is negative 6. But remember, we multiplied by a negative, and so our signs are going to switch. So now, I'm going to get rid of these. Now it's going to be a greater than, and this is also going to be a greater than. So how do we graph this? Well, I still need the numbers I'm working with. Here it's going to be negative 6 and 0 on the right. Make sure those are oriented the right way. They're going to be open dots like that. Okay, and then if you just kind of take it one piece at a time, I might cover this up. So this says x is greater than negative 6. Well, the x comes first, so it's going to be pointing the way our arrow is, which is to the right. So it's going to be shaded this way. Whereas this one here, that's not really written out nicely, but you can switch this so that if I have the x and then the 0 and switch spots, here it was pointing at the x, I'm going to keep it pointing at the x. And so I would read this as x is less than 0. So as long as your x or whatever variable you're working with comes first, you can shade the way that's pointing. If it doesn't come first, you can switch those, but keep it pointing at whatever number or variable it was pointing at. So here it's stuck in between those two values, negative 6 and 0. All right, let's try number 4. This was the last one for this video. A little bit harder this time. We have the quantity 2x plus 1 squared is greater than or equal to x times the quantity 4x plus 3. Now, it's tempting to just kind of apply that squared into our parentheses, but remember, that's not correct. If you think x squared, what does that equal? Well, it equals x times itself, x times x. So this thing squared is going to be it, 2x plus 1 times itself, 2x plus 1. And we have to FOIL that or distribute both of those into each term. Okay, I might bring this side down as well. 4x plus 3, like that. Now on this one, I'm going to take 2x times 2x to get 4x squared. 2x times 1 is 2x. Then I have to run the 1 through as well. 1 times 2x is 2x. 1 times 1 is 1. On the other side, we can distribute our x in. 4x times x is 4x squared. X times 3 is 3x. Okay, and I'm noticing one thing right off the bat here, and that is that I have a 4x squared on the right side and the left side. So if I go to subtract those, they are going to cancel. Okay, so those are no longer there. Okay, after that, I can maybe combine like terms. That's going to become 4x plus 1. I still have my sign. I haven't done anything special with that yet. Still greater than or equal to. This is going to be a 3x on that side. Now, normally, I like to move my smaller variable to the other side, which in this case would be the 3x. But if I did that, I would have both my variables and numbers on this side. And so I might actually move my variable this time and subtract, or my bigger variable, and subtract 4x and you get 1 is greater than or equal to. I just subtracted. That's not division. So our sign stays greater than or equal to. 3 minus 4 is a negative 1x. Now, when I divide by negative 1, I have an x. This is going to be a negative 1, but I divided by a negative, so my sign is going to switch now. So now it's going to look like this. However, my variable is on the right side. I want it to be on the left side, so I know which way to shade this on my graph. And remember, if I switch these two, x and negative 1, here, where was it pointing? It was pointing at the negative 1, so I have to keep it pointing at the negative 1. So when I go to graph this, we're going to have 0 and negative 1 oriented the correct way. It's going to be a solid dot, and here it's pointing to the right, so it's going to be all the values greater than negative 1. And you know what I just realized? I did not do my interval notation for either of these two. So let's go back and do this one. This starts at negative 6 and ends at 0. And it's encapsulated both with parentheses because these are both open dots. This one starts at negative 1 and ends at positive infinity. Okay? And we're going to have a bracket because it's a closed dot, and then infinities always get parentheses. So that is how you solve, graph, and write the interval notation for linear inequalities.